Hey guys, Mr. Bowman here. Another video on triangular distributions, and today we are learning to calculate the probability of non-standard portions using a triangular distribution. And before we get into the video, I just want to explain what do I mean by non-standard portions. So when we had our triangular distribution and we're calculating the triangle at the end, or maybe we're calculating this triangle here, um, those are standard questions where you're just very easily just using the left or right slope formulas to calculate the portion of those triangles. But there can be portions of triangles that are non-standard that aren't as obvious to figure out. And we looked at one in the earlier video. So for example, if you were trying to calculate this portion of the triangle, well, what you would actually do is you'd find the portion of that smaller triangle and then go 1 minus the probability of that to find the portion of the bigger triangle. And you can get more complicated questions as well. Maybe you've been asked to find the probability of that area, and what you would do is you'd find the probability of the big triangle and you would subtract the probability of the small triangle. So those are combined triangular events. And finally, you may also be asked weird questions that kind of go either side of the peak. What's the probability of it being between there? Well, what you'll need to do is you need to find the probability of the left triangle, probability of the right triangle, and then go 1 minus those. And that's what we've done there. So 1 minus the probability of the left triangle minus the probability of the right triangle. That'll give us the leftover portion in the middle. So we're going to go over one example that looks like these ones, and it's going to focus on this type of question here, where we've got a central portion, and we're going to be calculating the left and right portion, tails or ends, and then we'll find that the middle portion will be 1 minus those two tails. Okay, so I'm going to pause the video, I'm going to clear all that stuff, and we're going to get into some non-standard questions. Okay, so we're using the example from earlier. We are doing bus wait times and we are triangularly distributed. We have a minimum of 22 minute wait time, a maximum of 27, and the most likely wait time was 25. And in our question, we're investigating, well, what's the probability of a wait time being between 24 and 26. So first step, let's go ahead and label everything. So our minimum is A, our maximum is B, our peak is C. And here we have two x variables. So I'm going to write x1 and x2. And depending on the formula, we're going to have a look and investigate. So this is one of those weird scenarios. So what we're actually going to do, instead of calculating that middle area, we're going to calculate the area of that small triangle 1, and we're going to calculate the area of the small triangle 2. When we subtract both of those from 1, that will give us the leftover portion, which is the portion between 24 and 25. So let's have a go. So let's find the probability of 1. So the probability that x is below 24, so we're trying to find 24 or below in that direction, that is going to be equal to 1/2 times base times height. That's going to be 1/2 times the base, which is 24 minus 22, and that is going to be multiplied by our left slope height, which is in the formula sheet above, and we've got that up there and I've circled that. So that's 2 times x minus a divided by b minus a and c minus a as well. And from that, we're going to substitute in all those values. So we know 24 minus 22 is 2. 2 times 1/2 is 1. Anything times 1 is itself. So basically all of that is going to be cancelled out. X, in our case, we're talking about the x that's relevant to the triangle, which is 24. 24 minus 22. That is going to be divided by b minus a, which is 27 minus 22. And that is going to be multiplied by c minus a, which is 25 minus 22. And we carry on to do that math. So 2 times 2 up the top and 5 times 3 down the bottom. That is going to give us 4 over 15, which is 0.2667, and that was rounded to 4 dp. So that was area number 1. We then have to repeat that same process for area number 2, and that is the probability that anything is above 26. And like the first one, that's going to be 1/2 times base times height, and that is going to be 1/2 times 27 minus 26, so that's the base of that smaller number 2 triangle, times the right slope, and the right slope formula is up there, and that's a right slope because it's on the right hand side of that, and that's 2b minus x divided by b minus a, and then b minus c. And we're then going to go equal, so 1/2 times 1, well, that's going to stay 1/2. And then we've got 2, b was 27, x in our case, related to the x relevant to the triangle, which is 26. So do not write 24 for the x's here. B minus a, well, that's 27 minus 22. And b minus c, that's 27 minus 25. And we multiply that together, so that's 1/2, that's unchanged. The top is 2 times 1, which is going to be 2. And the bottom is 5 times 2, which will be 10. So that becomes 2 over 20, or 1 over 10. And as a decimal, that would be 0.1. So that means the probability of the second triangle will be 0.1. So just going to change pen colors here to finish it off for today. So we found the probability of triangle 1, the probability of triangle 2. We now need to find the probability of it being between 24 and 26. And that is going to be 1 minus the probability of the first triangle minus the probability of the second triangle. And when we do that, that's 1 minus 0.3667, and that's going to be 0.6333, and that has been rounded to 4 decimal points. So that would be our final answer. Probability of an event being between 24 and 26, or a 24 to 26 wait time for those buses, would be 0.6333. So just to recap, when we're doing non-standard areas, we may need to use our measurement and geometry skills. We may need to calculate the portion of other areas and then minus or subtract them from 1 to find a leftover portion. Hopefully you found this video useful. Now let's get into some questions.